Welcome to Tech Teach.
So into this datagram network, data communications, we need to send message from one end system to another. If the message is going to pass through a packet switched network, it needs to be divided into packets of fixed or variable size. So first of all, in packet switched network, whatever the data is there or the message there, it will be converted to packets. One of the disadvantages of circuit switch network is it is having a dedicated connection, and once it is having a dedicated connection, the other devices can't use that connection because till the complete data is transferred, other devices cannot use that link. Basically, to remove that, there is a packet switching. So into packet switching, there is no dedicated connection. If there is no dedicated connection, means anyone can send the data anytime, but the data that they will be sending, they will be sending in the form of packets. So complete data. So if suppose this is the length of the data, it will be divided into different packets. So these packets will be having like some numbering, and then it will be sent. So this will be sent in the form of packets. So this is the basic idea in case of packet switching. So in datagrams, these packets will be considered as a datagram. So each packet will be considered as a one datagram. The size of the packet is determined by the network and the governing protocol. So whatever the protocol is being used to transfer the data, that governing protocol or the network, they will be deciding like what should be the size of the packet. So we have just gone through the basics of datagram network. That is the part of the packet switching. So this packet switching is utilized only to have the resources available to each of the user that is connected to the network. In a packet switch network, there is no resource reservation. This is removing the disadvantage of the first, that is circuit switching. In that circuit switching, there was a reservation. There is a dedicated link between the shared source and destination, but here there is no reservation. Anyone can use. So resources are allocated on demand on a first come first served basis. So allocated on demand. So these resources will be allocated on demand. If a particular device wants to send the data, they will be asking for the resource, or they will just keep on sending their packet by converting the data into their packet form. So that will be the resources will be allocated based on the demand. So whatever the user wants to, or whatever device wants to send data, they will be asking for that and they will be sending. When a switch receives a packet, no matter what is the source or destination, the packet must wait if there are other packets being processed. So here in the switches, whatever the packets are coming out from other devices to the switches, these switches will be making sure like whatever the packet came first, that should be processed. Then only it will be accepting the other packets from the other devices. There is a chance like packets that are coming from other devices has to wait till the previously came packet is being processed. So once the previously came packet is processed, then only they will be accepting it. So there is a delay, or there is a wait time at these switches also. So like in the previous one, circuit switching, there was no delay at the switches, but in this case, there will be a delay at the switches. Here is an example of a datagram network. So first of all, these are the switches, but these switches are going to transfer the data in the form of packets. So that's why these switches are basically considered as the routers. These are called the routers. This is one thing. And here there are four users, A, B, C, D, likewise. So if suppose A and this is X, so A and X wants to communicate. So this is the complete data. So this data is divided into four different packets. So some smaller packets, it is divided. So 1, 2, 3, 4 packets are, it is divided into that. And it is connected with these switches will be called here as a routers. So these switches in datagram network are traditionally referred to as the routers. There are 5 different routers are there and 4 devices are connected. So here in a datagram network, each packet is treated independently of all others. So whatever the packets are there, they will be treated independently to other. There will be no relation like this is the first, so it will be given a preference. No, it is not like. So there is no preference given to any of the packet. And also based on the ordering, there is no nothing to if this is the first packet that is being sent, so there should be given a preference or likewise. So each will be independent to each other. So they will not be considered dependent based on the pattern or the order. They will be accepted by each of the routers independently. Okay. Even if a packet is part of a multi-packet transmission, the network treats it as though it existed alone. So if it is part of the multi-packet system or multi-packet data, even then also it will be treated individually. The packet in this approach are referred to as datagram. So in this case, these packets will be treated as a datagrams. Datagram switching is normally done at the network layer. So this is the point we should be noting it down. So this datagram switching basically takes place at the network layer. So if while going through the TCP IP model, we have already seen like the message that is there at the physical layer that is considered as frames into the data link layer, and into the network layer that is considered as the packets. So that's why, because this is a packet switching, so that's why it is, because it takes place into the network layer. So whatever the packet is there that is coming, so this packet is going to this router. This router will be transferring. So this router will be sending the packets in any direction. So it will be sending in two packet in here, third one is here, likewise. After going here, it can send one to here. So at the receiver end, these packets can be received in any order. So this order does not matter here. So once it will be receiving in any order, so after receiving, ordering will be done later on. Ordering is not governed by these routers. So our routers will not be responsible for any ordering of these packets. So each router that is there, so these each routers will be having a routing table basically in datagram networks. So routing single router is there. So this router will be having the ports, port 1, 2, 3, and 4. So these routers are having a router table basically, a routing table basically. So into the routing table, it is having the destination address. What is the destination address and output port? So that packet, particular packet that is coming. So at what destination it needs to deliver and through which port it will be delivered. So that is the routing table it is. So here in this type of network, each switch or packet has a routing table which is based on the destination address. So whatever is the destination address, based on that, there will be a routing table. Routing tables are dynamic and are updated periodically. So this is dynamic means it keep on changing and it will be updated periodically. How it is updated, we will just see later on. The destination addresses and the corresponding forwarding output ports are recorded in the table that as it is seen in the table. This is different from the table of the circuit switch network, in which each entry is created when the setup page is completed and deleted when the tear down phase is over. So in case of circuit switch network, there is also a table, but that table is only temporary, like till the setup phase is activated. Into the setup phase, the destination, source and destination, and to which port it should be going, that is given. And once the data transfer is completed, that is deleted. So here every packet in a datagram network carries a header that contains, among other information, the destination address of the packet. So it will be the datagram packets. So these packets will be carrying a header. So these header will be having some other information along with the destination address of the packet. So based on that, once it is going to through a particular router, whatever is the destination address, based on that, based on the destination address, it will be the router will be switching these packets to a particular port. Yes, I suppose the data is coming from the port 2, then it should be going to which port, that will be decided based on the destination address. So that is having stored into the routing table. When the switch receives the packet, this destination address is examined and the routing table is consulted to find the corresponding port to which the packet should be forwarded. So that is done with the help of the routing table. So packet should be going to which direction, that is given by the routing table. So whatever the packet is being received, so which packet will be forwarded to which router or forwarded through which port of the router, that is depending on the routing table. So it is having a routing table. Each router is having a routing table and the packet should be going to which direction, that is given by the routing table content basically. So whatever is the destination address. So here a switch in a datagram network uses a routing table that is based on the destination address that we have already seen. The destination address in the header of a packet in a datagram network remains the same during the entire journey of the packet. So this is the important point. So it is like whatever is the destination address, it will be constant throughout the journey of the packet. So if packet is started from, so either it is going to through whatever the routers, the address, the destination address will be always the same. This is how the destination address is constant into constant in the sense of the same throughout the journey of the particular packet till it receives the destination. What is the efficiency? So before going with the efficiency, we will see some more points related to the datagram switching networks here. So we will be just writing down like what different points related to the datagram switching circuits are there. So here, the datagrams that are traveling, they can follow different paths also. Okay, so while traveling, so into the datagrams, okay, so they can follow different paths. So we can write it down here also. So these datagrams can travel with the different paths to the destinations. It will be depending on either this router is having a free port or not, it is busy or not. So different paths packets can have packets can have different paths based on the availability of the space to a particular router. Okay, and these datagrams may not be receiving in order, not in order. So it is not necessarily that each packets will be receiving in orders only. Sometimes these packets, like it is going, it may lose. Okay, so sometimes packets can lose also. Loss in the sense drop, loss or drop. Suppose this is the case, sending this router is sending the packet to here, but suppose this is busy, it is not having the space, it can't accept this packet to send it forward, so it can drop this packet also. So there can be a loss, or also a router can drop the packet also. So that can be because of the lack of resources, or lack of resources means it is not having time to accept this because it is processing a previous packet, so it will not be accepting the particular packet. So if it is lost or it is dropped by a particular router, so at the receiver side, 2 will not be received. So if 2 is not received, then the because this packet, whatever the packet is there, that will be utilized by some other layer. So that layer will be requesting for again sending the same packet again. So that is the case in the sense in case of datagram networks basically. Sometimes this datagram network is called connectionless. So like in the circuit switching, there is a dedicated connection, but there is no dedicated connection. So that's why it is called like it is a connectionless network. So it is connectionless networks in the sense like whatever the here the packet switch does not keep any information of the source and the destination. So because these routers do not have, so these switches are called like routers, or sometimes it is called like packet switch. So initially in the circuit switching it was switch, but in case of datagram, it will be called like routers, or it is called like the packet switch. So this packet switch or the routers do not have any information about the state of the connection between a particular source and destination or likewise. So that's why it is called like a connection-less network is there. This is datagram network is considered as the connection-less network. And also in this one, there is no setup and tear down page. So no setup and tear down page is there into this because it is not going to establish a connection based on the request. So that's why there is no setup and tear down page is there. Each packet will be treated same by each switch. So each switch will be treating each packet as the same regardless of its source and destination. All packets are treated equal in this. So this routers will be treating each packets same. As this do not have the setup and tear down phase, so that's why there is a requirement of a routing table. So routing table is required because it is not having a setup and tear down phase, means it is not going to establish a connection. So as it is not going to establish a connection, the packets is going to start or deliver from the source to the routers. So routers should be switching these packets to which direction, that is decided by the routing table. So as there is no setup, means there is no address source and destination address storing at the switches. So that's why there is a routing table is required to give a direction to the packets that are coming from the source to the destination. So here the efficiency of a datagram network is better than that of the circuit switch network. Why? Because it is utilizing the resources efficiently. Here the resources are allocated only when there are packets to be transferred. So whenever there is a packet is to be transferred from source to destination, then only the resource will be allocated to transfer the packet. Otherwise, that particular other users will not be able to use the resources till there is a required or there is a demand. So that's why it is more efficiency is there than the circuit switching. So delay in datagrams. So here since all packets in a message necessarily travel through the same switches, the delay is not uniform for packets of a message. So its meaning is like, because we have just seen here, 4 packets are there. 4 packets, it is not necessary like always the packet 2 will be going through this path only. So that is decided by whether this router is free or not. Or once it is one is coming, so one is coming, so this one will be accepted by this router and it is transferred to this router, this direction. But next time if 2 is coming, it is not necessary then that like it will be transferring the same 2 packet to this direction only. That will be decided based on the availability of the destination router. So in that case, that's why here it is saying like not all packets will have to travel the same path. It will not be traveling by the same path. So that's why the delay is not uniform in case of the datagram switching networks basically. But there, what different components it will be there, we will just be calculating. As packet travels through 2 switches, there are 3 transmission times and 3 propagation delays. So what is the transmission time and propagation delay? So it is like if suppose A is there, if suppose a packet P1 is there and P2 is there. So if this is a device, it wants to send the packet. So while sending the packet from this is the link. This is basically the link. The A may take some time from sending the packet from A to link. So if A to link time is called the transmission time. So this is the time to send a packet from A to the link. So from A source to the link, whatever is the time, that is called the transmission time. And the propagation delay is, so propagation delay is once the packet is available at the link, so from this link starting to the end, so packet is transferring from here to here, that will be called the propagation delay. So first of all, transmission delay from A to this link, from A to this link, that will be the propagation delay. Then from this starting of the link to the end of the link, that will be the propagation delay. Okay, so that's why it is saying like if a packet is delivered from A to B, then what will be the different delays? So it is saying like as the packet travels through two switches, there are 3 transmission delays. So 3 transmission delays means this is first times, then here to here will be the first transmission delay, then second transmission delay, then from here to here, this is the third transmission delay. This is the transmission delay, 3 transmission delays, 3T. Then 3 propagation delay. So this is the propagation delay 1, that is tau, then again another tau, this is propagation delay, then this is the third propagation delay. So 3 times propagation delay. So this propagation delay is equivalent to slope of the line. So this is the line. So slope of this line will be the propagation, giving out the propagation delay. Then it will be again having 2 waiting times. So in case of these routers, because it is having a waiting time, because suppose it is processing some other packet, the coming packet has to wait. So there is the waiting time here. So this is waiting time 1 and this is waiting time 2. So waiting time 1 and waiting time 2. So overall, by ignoring the processing time in each switch, so suppose the processing time in each switch is not included at that time, in that cases, the total time that is taken is 3T, 3 transmission times plus 3 tau, 3 propagation delay plus waiting time 1 and waiting time 2. So this will be the complete delay that will be taken by one packet to transfer from A to B. So this is how the delay is basically calculated in case of datagram network. An example is given like switching in the internet is done by using datagram approach. In the internet network or internetworking, basically the switching basically takes place by using the datagram. Datagram switching network is basically utilized into the internet.